Assalamualaikum and a very good day to you all. In this video, I would like to share with you on how to solve implicit differentiation. So first thing first, let me show you several examples. Okay, usually we can differentiate something like this, right? Or maybe something like this. Okay, 3x squared lah. So this one basically dy dx equals 2, and this one is dy dx equals 6x. Okay, why is this so? Because what we want is that we want to differentiate this equation in terms of x. Okay, that is why we want to find the differentiation of function y in terms of x. Same goes to this one. Differentiate y function in terms of x. Hence the symbol lah. Okay, or maybe something like this, or 2 minus 3t squared. So we want to differentiate r in terms of t. Okay, so it's dr dt. So what we have is minus 6t. Okay, now these equations are all, these three equations are what we call explicit function. Explicit, why I spell it wrong? Explicit function. Okay, explicit function is where it's clear one variable is in terms of another. In this case, r in terms of t, and while these two, is the example of a function y in terms of x for these two, yeah, y in terms of x or x in terms of y. Okay, so these kind of functions are explicit. Now, how about this kind? Okay, now for sure for this one we will tend to make it yx plus 1 and then 3x cubed. Okay, and then what we have is y equals 3x cubed over x plus 1. Now in this case we can still express it explicitly. We can still express y in terms of x. Now how about if I increase the power of this one by 1? Okay, so no matter what you do, okay, we cannot express x in terms of y, okay, or y in terms of x. Okay, now this is what we call implicit function. Implicit equation of function lah. Okay, why implicit? Because we cannot express them explicitly. That is why this kind of function needs to be differentiate implicitly. Okay, now how to do that? Maybe we can consider this example. Okay, now this example of explicit function. Now for this one, what we do is we have why cannot? Okay, we have that one, the differentiate. Okay, what we do is we differentiate the left hand side by in terms of x, and the right hand side we differentiate in terms of x as well. Okay, so what we have on the left hand side is differentiate y in terms of x, we'll get dy dx. Okay, notice that this y, this is different, so it will be dy dx. Y is what we call dependent variable. Okay, while x is what we call independent variable. Okay, now as you can see over there, okay, so it become dy dx. Okay, now but for the right hand side, this is differentiate x squared, okay, in terms of x, and differentiate 1 in terms of x. So what we have is 4x plus 0. So from this example, what we can see two things. First, the differentiation of y in terms of x equals dy dx. Okay, while if the variables are the same, then we just differentiate it like naturally lah, like we always do. Okay, maybe some extra example. So y squared equals x squared plus 3. Okay, so let's differentiate both side in terms of x. So differentiate y squared in terms of x equals differentiate x squared plus 3 in terms of x. Okay, now this one is we differentiate as usual 2y. Okay, we bring the power in front and then copy paste y, the power less by 1. But since notice the variable are different, okay, so we need to put dy dx. Okay, now for this one, since it's a plus, so we can split them lah. Okay, plus d3 in terms of x. So this one become 2x plus 0. This one is 2y dy dx. So what we have is we can express dy dx explicitly. Ya Allah, why my dx is horrible? Dx. Now 2x over 2y. Correct. Okay, we simplify lah. We get x over y. Now we can proceed this one into to get the second derivative. Okay, so since we have dy dx equals x equals y, so we can differentiate the left hand side like this, and as well as the right hand side. Okay, now as you notice here, we have to apply quotient rule. Okay, so do one by one lah. We differentiate the numerator yu x lah. Okay, and then multiply with the denominator minus numerator multiply the differentiation of denominator over denominator squared. Okay, and then this one we differentiate the first derivative, it equals to the second derivative in terms of x. I made a mistake, it's supposed to be y. Okay, so this one is one more information lah. Okay, the previous one this one become this one, and then this one become that one. Okay, so let's continue. Okay, we make it nice lah. This one differentiate x in terms of x is 1 multiply y is y minus x. Now this one dy dx, what does this equals to? Okay, this one more or less like this one, more or less lah, but a little bit different. This one equals dy dx. Okay, so x dy dx over y squared. Now we want the second derivative to be in terms of x and y, so we might need to substitute what dy dx is. Dy dx is the one that we got over here, so we can ganti inside lah. Okay, so y equals minus x over y, correct, x over y, okay, over y squared. Okay, maybe I put y over squared here, then y minus x squared over y. Okay, and then 1y squared over x squared over y. Okay, and then y squared over x squared over y cubed. So this is the second derivative. Okay, so this is one way by applying the quotient rule. Okay, so from here we do here, but you can do the special thing about implicit is that we can take from the line before it, this one. if I take that one and I copy paste here, okay, 2y dy dx equals to x, and then I apply the same thing, which is differentiate left hand side and right hand side in terms of x. Okay, differentiate also the right hand side in terms of x, this one also in terms of x. Okay, why don't we try this one? We are doing the same thing actually, but we are applying different rule. Okay, just now as you can see here, we have to use quotient. Quotient. Okay, some student might be easily intimidated by lebih kurang tu, like that lah, feel scared lah. Okay, you are very scared when you see this quotient rule, right? Okay, but this one is way easier because this one we are using product rule. Okay, so product is easy. We differentiate the first one, okay, multiply the second one, and then plus, and then the first one just write, copy paste, differentiate the second one. Okay, so as you can see over here, no quotient rule involved. And then right hand side easy lah, because xx equals just differentiate as per usual, 2 over there, let it be. We will let it be lah, constant already. This is one we need to be concerned with. Okay, so this one yx different, so differentiate 2y as usual, 2, but must put dy dx at the back, multiply another dy dx. Okay, and then plus 2y multiply by this thing. This thing is the second derivative. Okay, like that. Okay, notice that the second derivative here, okay, it is not equal to this one. The blue box simply means dy dx squared. It means the first derivative squared, the square of the first derivative, while this one means the second derivative already. Okay, 2. Okay, as you can see, some of you might notice this 2 can cancel. You want to cancel also, can lah. So now, what is our dy dx? In the green bracket, dy dx is x over y. Okay, so x over y squared plus y d2y dx2 plus 1. Because the 2 we cancel already, right? Okay, so y d squared y dx squared 1, and then this one minus x squared over y squared. Okay, we want to combine this 1 and x squared minus 1 becomes y squared minus x squared over y squared. Okay, and then this one copy, and then no need lah, maybe bring this one over here. Okay, and then we want to bring these 2 over there, so y squared minus x squared over y cubed. As you can see, the answer is just the same. The process is different. Okay, if you want to use quotient rule, then you take the last one what you have. Okay, but if you hate quotient rule, then you might want to take a line before the dy dx over here. Okay, so you take this one lah, this box lah. Okay, and then you proceed here, and then you differentiate both sides in terms of x. Okay, so I hope I hope this video is beneficial for you. Thank you for your time and attention. Assalamualaikum and have a good day.